When overriding methods, the contents of the overridden method can be included in the method that is overriding it by using the reserved word super. Using the example we worked with in the previous video, say that for whatever reason, we want the return statement of the toString method of the CPU class to include whatever is in the toString method of the computer class, the class it inherits from. We can do this by adding the reserved word super followed by the method from the parent class we would like to add, which in this case is the toString method. Now when we make a call to the toString method from an object instantiated from the CPU class, in this case the object's name is myCPU, we can see both these strings. This is an example of method overriding, and this is the toString method of the CPU class, are printed to the console. We can add a \n here to make this a little easier to see when we run the program, like such. Now, we can use the reserved word super to invoke any method from the parent class. In other words, just because we are using super in the toString method doesn't mean we have to use the toString method from the parent class with super. For example, if we create another method in the computer class called powerOn that simply returns the string computer is on, we can go back into the CPU class and change toString here to powerOn. And when we run the program now, we see we get computer is on followed by this is the toString method of the CPU class printed to the console. We can even use the reserved word super to grab the value of a variable in the parent class. For example, let's create a protected string variable in the computer class. We'll call this variable computer name and we will initialize it to Bob. Now we can go back to the CPU class and change super.poweron to super.computername. Now when we run the program, first Bob is printed to the console, followed by this is the toString method of the CPU class on a new line. In case you're wondering why the word super is used for this, it's because super is used to reference members of the superclass from the subclass. Remember, superclass is another name for a parent class, and subclass is another name for a child class. Looking at another example, let's look at how super is used with constructors. To do so, we will add a constructor to the computer class. This constructor will consist of a simple print line statement that contains the string computer is running. Next, we will create another constructor in the CPU class. This constructor will begin by utilizing super. By typing super itself, the compiler knows we are referring to the constructor of the parent class, or superclass. Next, we will add a print line statement that prints the string CPU is on. Now if we go back into the main method here and instantiate a CPU object, when we run the program, we see the strings computer is running and CPU is on are printed to the console. That is because the constructor of the CPU class is called in the instantiation of the CPU object, and that constructor invoked the constructor of the computer class through the reserved word super, then printed an additional string following the output of the execution of the computer class's constructor. Keep in mind, super must be the first statement within the child class constructor. If we move it here, we will get an error that tells us exactly that. Now, even if we remove super completely from this constructor, notice when we run the program, we still get the contents of the computer class's constructor printed to the console. That is because even if super is not used in the constructor of a child class, the parent class constructor will always be executed before the statements of the child class constructor are executed. That is by design of the Java programming language. Now say we had multiple constructors in the computer class. For example, let's create another constructor that takes a string as a parameter, and instead of printing computer is running to the console, it will print whatever name is input is running to the console, like such. We can also add a second constructor to the CPU class that also takes a string as a parameter. And now we can invoke super using the supplied string as a parameter to super. Going back to the main method, we'll instantiate a second CPU object called otherCPU, and when we do so, we will provide the string Bob in the parentheses as a parameter. Now let's run the program. Notice the first two lines are still using the parameter list constructors of the computer and CPU class, but the second two lines are using the constructors we just added because we provided the parameter of Bob. If we remove the parameter list constructor of the CPU class, we will get an error in the main method here because there is no defined constructor in the CPU class that has no parameters, only one that requires a string as a parameter. If we add that back and instead remove the parameter list constructor of the computer class, we will get an error on the parameter list constructor in the CPU class. That's because if we do not explicitly make a call to super, a parameter list constructor is called by default, and if we do explicitly call super with no parameters, the compiler is looking for a constructor with no parameters in the parent class, which we just deleted. This is explained in the Java docs here, where it says, if a constructor does not explicitly invoke a superclass constructor, the Java compiler automatically inserts a call to the noArgument constructor of the superclass. If the superclass does not have a noArgument constructor, you will get a compile time error. Object does have a constructor, so if object is the only superclass, there is no problem. Looking at the last sentences on this page, we can see that if a subclass constructor invokes a constructor of its superclass, either explicitly or implicitly, you might think that there will be a whole chain of constructors called, all the way back to the constructor of object. In fact, this is the case. It is called constructor chaining, and you need to be aware of it when there is a long line of class descent. Looking at this example again, what that means is, if we created another class that inherits from CPU, the constructor of that class will call the CPU constructor, which calls the computer constructor. So in total, 3 constructors will be executed. Adding any more levels of inheritance will continue to add to the total number of constructors executed.